So hi all, in today's DT video, we are going to see about scheduling algorithms. First of all, before seeing the DT of any scheduling algorithm, we have to know what is actually scheduling and what are the things happening inside the scheduling. Scheduling is nothing but we are going to speak about the process which has to enter the CPU, and this duty has to be fulfilled by the process manager. It is the full authority of the process manager, like he has to pick any process and he has to allow the process to enter the CPU, and once the work is over for the particular process and it has to be reallocate and one more process has to enter the CPU. So based on this scheduling algorithm, we have normally in operating system we have 4 scheduling algorithms. That is, the first one is FCFS, that is first come first serve, and next is round robin. In short, they will say as RR. And what are the other one we have? Priority scheduling we have, and shortest job. So these are the we have 2 types like preemptive and non-preemptive. So the major scheduling algorithms are these. Okay. So in this DT video, we are just going to incorporate this DT design thinking framework into the first process. I mean, first scheduling algorithm called as first come first serve, that is FCFS. So among you two, who is going to explain empathy? You know, like you have 5 phases in DT, that is empathy, define, ideate, prototype, and test. We will be seeing this first 3 phases today, that is for this scheduling algorithm, because we don't have the provision for testing. Just we can explain as an example, and we don't have what was it. The testing part can't be done for this particular algorithm. So who is going to start introducing this?
I'll be starting with the empathy pattern, and I'll also continue to explain what is define. So first of all, what is empathy is that we need to go into the customer's shoes and understand what are the problems they are facing. So by facing these problems in OS, we get to know about these scheduling algorithms and we are making use of it. So the first thing is that we need to understand the goal, and also there is a need to bring out these problems and solutions in order to overcome these obstacles. So the first point is we have to look into the end users. So we need to see that the frustration caused by the slow or delayed process that is not allowing them to accomplish their task. So we need to understand that, and according to that we have to give the solution. And also we need to gather the feedback. What are the feedbacks they are or their opinions that they are producing in order to where we can just understand the problem and give the solution. And the third point we have to understand is that the developers, apart from the other persons, the developers need to understand from the customer's side, and they need to gather the prior information, and they need to opt for the proper scheduling algorithms. And this will allow us to gather the meaningful insights, and it will allow us to face the challenges and bring out some of the best mechanisms to overcome this. So first, empathy is that we need to understand the problem from their side and give them the solution. So the second part I'm going to explain is define. So define is what is that? We need to see or analyze where the problem generally arises. So the first, most important thing is that the problem may be achieved through the unfavoring or gathered insights, or some of the insights which we don't feel like we need to bring it into consideration. So when these problems arise, let's take an example in operating system. So when we need to accomplish some task, when there are multiple processes waiting in the order to accomplish their task, we cannot allow all the processes to accomplish in the same time. So we need to, there comes a waiting state. So these are the terms: waiting time, turnaround time, and all these average time. These are the terms used in the scheduling algorithms. So when these problems arise, we, as you told me, there are generally 4 types. The foremost important 2 things discussed is first come first serve and the round robin schedule. So in first come first serve, we need to understand the priority goes to it. So we have to understand where the problem arises, and according to that we need to assign the solution. So this is all about the fundamental. As we were discussing about empathizing and defining, and I guess one of the most appropriate solution for this problem could be round robin. in round robin scheduling, it is a type of CPU scheduling as we all know. And in this scheduling type, we will be using a time quantum. So by using this time quantum, we will be splitting the processes according to the ready queue in a timely manner. That is, each process will get a chance to be executed in the CPU for a particular amount of time. For example, let's keep the time quantum of 2 seconds, and there are 3 processes. For example, the first process arrives and has the time quantum of 8. The second process arrives and has the time quantum of, let's say for example 11, and the third process arrives and the time quantum of it is, let us say for example as 8 once again. So since by noticing the arrival time, the first process will be executed first. But the irony is that the first process will be executed only for 2 seconds, and as the time quantum is only 2 seconds, so the first process will be executed only for 2 seconds, and the rest of the time in the first process will be executed later after the execution of second process and the third process within the time of 2 seconds each. So let us say this has a very good advantage because it sees in fairness for all the processes. Yes, as it allows each of the processes to execute itself for time quantum. There will be a cycle of processes executing itself, and also it is very easy to implement and it is easy to understand for us people. And also we can also notice that the implementation requires no starvation of the processes. So I guess it will be one of the most useful scheduling technique for this problem statement.
So let me conclude, right? We have seen 2 scheduling algorithms, one is FCFS and round robin. So as compared to FCFS, it is most efficient one, which one is round robin. What is the efficiency is no process has to starve. Starvation problem is not there in round robin, but starvation is there in what FCFS. And then all processes are getting a chance to enter the CPU based on the answer. So I conclude like it is far efficient compared to